Hello, I'm Steve Harrington from Flometrics. I want to introduce you to our pressure pulse generator that's used to simulate arterial waveforms and to test catheters like this and disposable pressure transducers. First step in using our pressure pulse generator is to calibrate the PPG and measure the performance in terms of millimeters of mercury output that you get for each volt of input. So the PPG system creates a pressure for each volt, and we figure out what that ratio is. So now we can go ahead and do an attenuation test where we measure how much this catheter changes the pressure waves that come from the pressure pulse generator to this disposable pressure transducer. So the first step is to calibrate it and make sure that the reference transducer and our disposable pressure transducers are reading the same. Okay, now we're going to go ahead and run the sweep from 10 hertz to 300 hertz and measure the performance of the disposable pressure transducer as compared to our reference. You can see that waveform definitely changes, and we are noticing a natural frequency of our units under test and the damping coefficient, so we can assess whether this is a good catheter for measuring an arterial waveform. So we can save these files as a PDF or an HTML if we want to. The other thing we can do with our pressure pulse generator is get a custom waveform response. Once again, we double check that the pressure transducers are measuring the same pressure, and then we can go ahead and load up a waveform and play it. In this case, we'll be playing a typical arterial waveform that you might see in the operating room. So we're going to go to the bottom of the page, go ahead and load a waveform, make sure that it's set up for a comma delimited data file. We have a CSV file here of a typical heart waveform. It looks good. So we can go ahead and run this test. And we can see that the waveform generated is just like the one that we loaded up. Once again, we can save the data if we want to. We go back to the main page here, and if we want to, we can do a manual pulse train response and see how the pressure transducers respond to a square wave, for example, or a triangle wave, or a sine wave. Once again, we're going to calibrate the system, make sure that our pressure transducers are still agreeing with each other, make sure that no one took apart the system and changed it in between the time that we last did a calibration. This time we're going to test square waves. So you can hear the ringing sound as each square wave is produced. We can save this data file if we would like to again, or we can go back to the main page, and that's basically how you use the system.